Good morning. Go ahead and take out a piece of paper so that you can take notes with me as we go through our lesson. We are going to continue working with ratios, and today we're going to look at how to use ratios and a ratio table when finding missing side lengths of shapes. Ratio tables can help us pick out similar triangles. The problems we will review in these notes will help you on the practice handout you will be given after we are done. Let's look at these 4 triangles. I'm going to try to draw them so they all look the same, but I may not do a perfect job. I drew 4 various triangles, trying to keep them with the same shape, and now I'm going to add my measurements to my 4 triangles. You may notice that the picture and the measurements may not necessarily make sense. For instance, on this last triangle, the side of 8 actually looks larger than my first triangle with a side of 10. When you encounter problems like this, always refer to the numbers instead of the picture. I'm going to shade in the first triangle so that you will know which one I am referring to. We are going to try to pick out which triangles are similar to this first shaded triangle that has side lengths of 10 and 25. And we're going to use a ratio table to help us determine this. Let's draw out our ratio table. Remember, a ratio table is a collection of equivalent ratios, so you can make it as long as you will need it. I am going to put the vertical side, which my 10 represents, this is the vertical side of the triangle, over the horizontal side, which is what the 25 represents. So in my shaded triangle, I have a vertical side of 10 and a horizontal side of 25. Now I am going to try to decipher which of these triangles are similar to them. That means that they are in proportion, or they are the same ratio. Before I start looking at the numbers, I'm just going to play around on my ratio table. I noticed that with my 10 and my 25, that if I divide both numbers by 5, I have another equivalent ratio. 10 divided by 5 is 2. 25 divided by 5 is 5. You may notice when you glance back up, there is a triangle of a vertical side of 2 and a horizontal side length of 5. So this means that this triangle is similar to my shaded triangle. I'm just going to continue playing around with numbers on my ratio table. For instance, I'm just going to double this one. 2 times 2 is 4, 5 times 2 is 10. I notice that there is no triangles with those measurements. I may double it again, 8 and 20, and we'll notice that a triangle with these measurements are also similar to my shaded triangle that I started out with. My ratio table has shown a collection of equivalent ratios. Now, what is the scale factor? You will be asked questions about the scale factor, so this will be important notes to take down. The scale factor, or in other words, is saying how much larger is the horizontal side than the vertical side. To find the scale factor, I'm going to take the horizontal side of 25 and divide it by the vertical side of 10. I'm going to get the answer of 2.5. So the horizontal side is always 2.5 times larger than the vertical side. When I look at my ratio table, I can see that every number that I used for my vertical side, I could multiply it by 2.5 and I would get the horizontal side. A tape diagram works really well when we know what the scale factor is. Let's look at what this method of solving problems looks like. I'm going to represent the scale factor using the tape diagram like this. This sized bar on the tape diagram is going to represent 1. So to represent 2.5, I'm going to draw 2 bars of that size and half a bar. Now to show you how this works with our first shaded triangle, 10 was the vertical side, and we learned that the horizontal side was 2.5 times larger. So that means I would have 10, 10, and half of 10 is 5. Here are my 2 whole pieces and my half a piece, leaving me with a horizontal side of 10 and 10 and 5, which is 25 for my horizontal side. My vertical side was just the 1 piece of 10. So let's look at a different problem. Let's say that I know a vertical side is 16. Using the tape diagram method, I would be able to say it's 2.5 times larger, the horizontal side. So I would have 16, 16, and what is half of 16? 8. So my horizontal side would be 16 plus 16, which is 32, plus 8, which is 40 for my horizontal side. Let's look back up to the ratio table. If I were to extend my ratio table, so I do have a side length of 16, would I get a horizontal side of 40? I would. I can check this several ways. 4 times 4 is 16, so 10 times 4 is 40. I think with those notes, you should be able to successfully go over today's assignment. If you need to rewatch this video to get your notes, you may do that as well.